Hello, I'm Extra Life. Today we are going to be putting together the Super 16 through-hole PCB and panel set using a parts kit of all of the individual through-hole parts that we need to build this project. This is going to be a very dry, very long, very technical video. I'm going to try and keep it mostly unedited so that you can see all of the steps. So if you're not building this, I can imagine you won't have much interest in it, so feel free to go watch something more interesting. Maybe I'll put a link down in the description. But if you are going to build one of these, I recommend you watch the whole video because there are a couple things that might not be apparent at first, even if you've built other through-hole projects before. So I'm just going to give you kind of a quick preview of what those might be. When you're mounting the two boards together, you're going to use header pins. You want to make sure to align those before you solder them. You don't just want to stick them in and solder them and then hope they go together. And then the same principle is going to apply on all of the components that stick through the front panel. So that's going to be the potentiometers, the jacks, the encoders, and also the buttons that, the button caps that stick onto the switches we're going to mount, as well as the LEDs that poke through the front panel. You need to have the front panel mounted. And if you've done your rack modules before, that may all be very straightforward. I still encourage you to watch and see how the panel mounts and what order these things kind of get assembled in, because this two-board stack up and the arrangement of the components on the front panel might not be how you've done it before. So obviously you're going to need a soldering iron and some solder. I'm using a Heco FX888D and some lead-free solder. As well, we're also going to need some flush cutters for clipping resistor leads. Might need some pliers to move some stuff around. And it's always helpful to have tweezers if you need to move something that's in a restricted space. And we're going to need some sockets for tightening the jacks and the potentiometers and the encoder. You may also want a multimeter so that you can do a continuity check for short circuits before you plug it into power. You probably also want a circuit board holder of some kind. This is a cheapo Velman one. It isn't strictly necessary. You can do this project without one probably. But once you get the front panel on, it can be tricky to hold it without the sort of components getting poked back through the board. So I really recommend having a board holder. And last but not least, you probably also want a fan so that you can clear the solder fumes from your workspace while you're soldering. So I'm going to try and keep this off except when I am actually soldering, just to minimize the noise, but if I forget, please forgive me. So the order we're going to do this is pretty straightforward. We're going to do the smaller board first. This is the CPU board. And this has the microcontroller, and it also has the most difficult part, which is the SOIC 8's memory chip. And we're going to do that first because it is actually very straightforward. If you've never done SMT soldering before, don't worry about it. It'll be a piece of cake. We can actually do this laying flat on the ground. We're going to grab ourselves the little SOIC 8 package. Now this comes in a little bit of a reel that is used for automated assembly. Get that like that. You can see it's in a little tray, and then there's some very thin shrink wrap type plastic on top. What we want to do is peel that back and hopefully not have it go flying across the room. And then once we peel that off, we can just dump that onto the table as we like. And what we're going to do is we're going to locate the dot. So pin 1 is next to the dot on the chip, and there's a dot on the circuit board where pin 1 needs to go. So hopefully you can see that up there in the top left corner is a little dot. We're going to start by putting a little bit of solder on one of the pads, and I'll just put it on pin 1 here. So I'm going to clean the tip of the iron, put a little bit of solder on the tip. And this is lead-free solder, by the way, so if you're doing lead solder, then it'll be easier. And you may also want to wear gloves if you're doing leaded solder. And I'm just going to tin the pad. And you can probably see there's just now a little bit of solder on the pad itself. So once again, make sure that the dot on the chip is on the same side as the dot on the board. Pick it up with the tweezers. And we're going to try and kind of hold it in place while we heat up this pad and flow the solder. So now you can see the chip is soldered in place and it wiggles a little bit, but it's not going to move. So now we want to pick it up and visually inspect it and look from the edge on to make sure that all of the legs of the IC are actually touching the PCB, because what can happen is it can be up at an angle and not quite flush with the board, and then it's harder to solder. Edge on. You can see that it's very flush with the board. Now I'm going to use some flux, and this is kind of the most important thing with SMD. If you haven't got this, it can be sort of a pain. You can also use solid flux. So this is a flux pen, liquid flux, and you kind of dab it on with the end of the pen. And this is solid. I mean, it's more like a gel. It's sort of a paste. And just sort of smear it on the legs of the chip. And this is going to make sure that the solder can actually flow onto the pads and the legs. I'm going to, once again, clean the tip. And then we're going to sort of build up a little ball of solder on the end of the iron. And it doesn't matter that the flux is kind of burning up, because we're going to use the flux that's on the legs of the ICs here. And I'll just touch it to one of the pads. And you can see we formed a solder bridge, but that's all right. We'll get rid of that in a second. And I'll just do that to the other legs. See, we're looking at that solder bridge. First way, of course, is to get our iron nice and clean, and then just touch the legs and try and draw the heat away from it, sort of towards one side. And just like that, just by using the tip of the iron. But again, that depends on having lots of flux in the joint so that it can still flow properly. If you don't have enough flux and you're getting lots of bridges between the two legs of the chip, then you've got to apply more flux. So just kind of for fun, let's blob on some more solder here. See, we've got a big bridge there. The other thing we can use that makes this very easy work is solder wick. And this is just stranded copper wire. If you haven't got any solder wick, you can use just regular copper wire and just, strip the end of it and get yourself a nice sort of beefy piece of it like this, like, maybe fold it back on itself so you've got a little bit of mass. And then this, you can also put flux on this stuff. Usually there's some inside of it. But all you do is put the wick on top of the legs, apply some heat, and then wait for it to kind of flow into the solder wick and then pull it away. And that's it. So I'm going to do the other side. Once again, there's already flux on there, so I can just dab a little bit of solder onto the iron and do each of these legs. But now I'm going to grab just a paper towel and clean up that flux residue. But depending on the flux, depending on the solder, some of it can eventually become conductive, so you generally want to clean it off if you can. And you can just use water or rubbing alcohol. And it sort of helps the board look nicer as well. So there we go. That is the hardest part. That is soldering on the SOIC 8 WinBond memory chip. And once again, we'll just double check that we've got the dot in the same corner as the dot on the PCB. Now we're ready to do resistors. So with PCBs, generally through-hole PCBs, we want to assemble them bottom up. So we do the shortest components first. So we've got R103, R108, R113. There's a great tool called KiCad Interactive BOM, and I will have a link to that down in the description for this board so that you can kind of use the mouse and highlight parts, highlight values, see where they go. So if you've got something on the BOM list and you're not sure where it goes, you can just look it up in the interactive BOM. But for the most part, all of the values are printed here, and you can just look at the values. If you don't know how to read resistor codes, you can just use a multimeter to test the resistors. Or for the kits, they will have the ohm value just written right on them. So we're going to start with the 1K resistors in R103, 108, 113, and 116, it looks like. So I just orient those so they're all in the same direction, so that if you're reading the color codes, it's easy to read them when they're on the board. You can see some of these are quite stiff. What we do is just grab the pliers and kind of pull it. And you can see I'm skipping some because the rest in this row are 10K. So there's two ways to do this. We can either do it from the top or from the bottom. Traditionally, you flip it over and solder it on the bottom because that's where you want your mechanical strength. So I'll do this row like that. So we heat the leg and the pad, and then we apply a little bit of solder. Heat the leg and the pad. Oh, and I should have the fan on. You want to do is clip these one at a time. If there's a bunch in a row, the temptation is to clip a lot of them at once. And you just want to clip them so that you don't really touch the solder at all. You just are getting the wire. So now I'm going to show you the alternate method for soldering, which is to do it from the top side. And basically you just do the same thing. You just heat up the leg and then apply some solder. And it can be harder to get to the components, but for resistors it's usually quite easy. I mean, they're the first things on the PCB, so there's a lot of clearance around them. So you can see with this joint, we've got a big blob of solder on there. So that means it is a cold joint. We have too much solder and not enough flux. Apply a little bit more flux and try and reflow that. There we go. That's better. On the bottom, we want to be sure that we've got solder flowed all the way through to the pad on the other side. And some of these look a little bit light, but they all went all the way through. I can't see any space in the annulus of the via. So that looks all right to me. And then again, you can kind of see here how it's difficult to reach the resistors from this side. Just flip the board over. Don't make it hard on yourself. When I started shooting this, we had plenty of natural light, but then it got cloudy all of a sudden. So, and this one, as you can see, for some reason has a 5-color code. That's why I have never liked the color codes. Even if you learn one, you still don't know how to read them all. I'm going to move on to the diodes and the inductors. And I think in the parts kits that I'm making, the inductors will be in a separate bag labeled other or miscellaneous, and maybe also the crystal will go in there as well. Here are our diodes and inductors. And let me just kind of zoom in to show you how to identify them, because it might not be obvious at first because they're not really labeled. So these big resistor looking things that are a little bit darker brown, these are the inductors, and they go right here. This is a BAT85 diode. This goes on the other board. There's these two, which are glass diodes with black stripes, and they have slightly thicker leads than the BAT85. These are our Zener diodes, the 4733A, and they go right here. And these are our 4001 silicon rectifier diodes. They're black plastic with a silver stripe, and they go over here by the power connector. And you'll notice these, of course, are polarized. They have a black stripe on one side, or a silver stripe on one side. That's on this side. And that lines up with the white stripe on the PCB. So you can see there's an additional stripe on the symbol. So you make sure that the silver stripe on the diode lines up with the stripe or the line on the silk screen. And both of these face the same way. While we're here, I will just put in the inductors. And these are passive devices. It doesn't matter which way they go. This is the ceramic capacitor bag. And we have a bunch of these 0.1 microfarad or 100 nanofarad capacitors. These are the most common. We have a couple of these 22 picofarads and a couple of these 100 picofarads. So on this board, we've got two 22 picofarads over here next to the clock crystal. So these capacitors really have to be bang on. So if you're building this just from parts you've got laying around, do be careful that these clock capacitors are exactly the right value. And then we'll just grab a bunch of these 0.1 mic or 100 nanofarad capacitors. And you notice I'm just pulling these out from the masking tape. Unless the parts are very old, that generally works better. Okay, so I've just discovered that my previous bill of materials was missing one part, which is this 22 picofarad capacitor, and that would go right here in C114. However, I have just looked at the schematic, and all this is doing is buffering the output of the auxiliary control voltage digital to analog converter and the op amp. So it isn't really necessary. All it's really doing is making sure that the slew rate of the CV output stays in spec, which isn't terribly important because it's actually just jumping from point to point, and so that's limited in the chip itself. So as an experiment, I'm just going to leave this out, and I think for the most part we're going to call it an optional part if you have plenty of these laying around, and I'll put this in the kit so that you can just have all of them. But if you've already bought the BOM, then you can probably do without it, and we're just going to build it without and test it to see how well it works. So we will move on to transistors. Now here is my transistor package, and in the kits these are actually going to come in an anti-static bag because these MOSFETs are a little bit sensitive. 2N7000s, where are those? These, the ones that there are 4 of. These are your sensitive parts, so you really just want to make sure you touch something large and metal and grounded before you handle these, and pull these out one at a time. And these go over here at the edge of the PCB. And these are, of course, oriented in such a way there's a round side and a flat side. You want to make sure the flat side goes towards the center of the PCB and the round side towards the edge, and that is indicated on the silk screen. Alright, up next we've got the voltage regulators. The 3.3 volt regulator looks a lot like a transistor, but there's only one of them, and that's the only one in this package. And again, that needs to be oriented with the flat side towards the flat side on the silk screen. And now the 5 volt regulator, which is a bog standard 7805 regulator, LM7805. So what I like to do is take each of these legs and just fold them down at a right angle. There's a thick part and a thin part. It should bend kind of right at the joint between the two, and have it sit nice and flush on the board. And that way you'll get a little bit of thermal transmission. You can actually put a screw here, but you just want a little bit of contact so that the heat travels between the circuit, between the component and the PCB. So I'm going to screw this down and then hold the voltage regulator with one finger against the PCB and then solder one of these legs. You don't want to solder the middle one because that is the one connected to the tab, so if you heat it up, then you can burn yourself. And now the board is kind of held in place, or the regulator is held in place, and it has good thermal contact with the board. And remember, this has quite a lot of thermal mass because this middle pin is connected to this big metal tab. So for the most part, we want to avoid heating up the whole tab. We just want to get in there and get out relatively quickly. Pins are slightly thicker. I like to cut them from the wide side, but you can do it however you like. Just be aware that they might come flying off because it takes a little bit of force to clip them. Here is the crystal. It comes in a nice little metal can. You can see it says 16 megahertz on it. And some of them even have the required capacitance written. It might say 20 picofarads or 22. But it's not polarized. You can put it in either way. Although you do want to be gentle with the leads. And then just solder it in place like you would a resistor or a capacitor or any other standard through-hole component. So now it's time to do the ICs, and they'll come in this little anti-static tube like this. The other tool you might blade, and so they won't quite fit into the parts. Now you can just set them on the edge of a table or any flat surface and bend them in a little bit. It doesn't take much force. I'm just kind of pushing from the sides. You want to get all of the legs parallel, so it's important to use a flat surface for this. And if you do it with your fingers, it's actually a lot more difficult. Of course, if you have one of these, you want to make sure that it's grounded, touch it to something metal. There's a little grounding screw here that I sometimes use if I'm doing a lot of chips. And there's two sides. There's a wide side and a narrow side. These are all narrow chips. And you just squeeze those together, and you should have made that perfectly parallel. When we install these chips, we want to be very careful to get the right orientation. You notice there's a kind of divot and a dot over on one side of the chip, and that matches with the divot and the dot on the IC itself. Okay, like that? And that is pin 1, and that is where this dot goes on the board. So we set that in. And there we go, that's what we want. So you notice there's enough friction to pull it out. Sometimes there's friction, sometimes there's not. If you're very lucky, there won't be. So since we've got friction, we can just flip this over and solder it. But if there is no friction, then what you can do is take some of the legs after you stick it through and then push them over so that they hold the chip in place. So I like to do one in each corner. Now that we have this in place, I'm just going to solder all of the pins. And again, I set my soldering iron at a little bit lower temperature, so we'll see if that works. But we just want to get in a rhythm and do each of these pins in fairly quick succession. And now we're going to do an inspection, and you can see that this pin right here has been bridged, so that is a discovery that we've made thanks to our close inspection. And we'll just look at this at an angle and make sure that we haven't got any other bridges, or that we have enough solder on all the pins, that we haven't left anything floating or forgotten anything, because that's a lot of pins to do at once. We didn't do them all in order, and we just want to be very careful that we get them all. Get this to unbridge itself. There we go. These two obviously are the same size, so we don't want to mix them up. We want to make sure that we put the right chip in the right place, otherwise it's not going to work very well. So this 8-pin chip is a TL072, and it goes in the slot labeled TL072. And once again, there's a dot on the chip, and that needs to match the dot on the PCB. Down. And this one, as you can see, is much looser, so when we flip it over, it may want to drop out a little bit. So once again, use the screwdriver and bend these leads in the corners so that it can't drop out. And last but not least, we need the digital to analog converter. Once again, we've got a notch and a dot on one side, and so we'll position that to match the silk screen on the PCB. Hold that in place, form the leads, so We've got 4 electrolytic capacitors. There's these circular shapes here with the dots. We've got 3 47 microfarads and 1 330 microfarad. So the one that I put on the bill of materials ended up being this very tall one. The ones that will come in the parts kits are a little bit smaller. But let me just show you right now how I would use this one. But you can't just put all the electrolytic capacitors in straight on. Particularly these on the main board, they need to be folded flat so that they fit underneath the front panel. On the back, it really doesn't matter, but again, as we want to minimize the height so that this will fit in shallower cases, just pop it out a little bit and then fold the leads over and then have it rest on top of this IC essentially. And what we'll do is solder it in like this, and then we'll come back with some hot glue and affix it to the top. The leads over, and again, these are polarized. So we've got a stripe on one side of the capacitor, and that needs to match the white section, the negative line, on the PCB silk screen. We have now got that capacitor in more or less as flat as it can be. And the others are not going to be any shorter than that, so we can just put them in the way that they're sort of intended to go. Once again, making sure that the stripe on the capacitor lines up with the white section on the silk screen. One microfarad capacitor over here. Once again, the stripe. So now all that's left to do are the pin headers. And it's important to know that these 2 long pin headers on the edges actually are soldered on this side and poke through onto the other side so that they can connect to the board. And then this pin header and this pin header are soldered on the other side of the board and poke through onto this side. We'll start with these 2, which are the power connector and the ICSP header. Now, the way that I like to install these is to use hemostats. These are locking tweezers. They've got kind of a spring in the back here. And what you can do is kind of grab this and hold it in place and then flip the board over so that it stays through like that. That is the easiest and safest way to do this. The other way you can do it is to set up the board in such a way that you can hold them with regular tweezers and also have some solder in your hand at the same time. Another way to do it would be to use tape. You could use Kapton tape, polyamide tape, but if you haven't got any of those and you've just got your hands and some tweezers, you can still do this. So I grab the tweezers and then with my pinky and my ring finger, hold the solder and then kind of have that in place. And then very carefully get some solder onto one of these legs. Now this requires more coordination than is strictly required for soldering stuff, but you can see it is possible. We do want to make sure that this is flush, so you'll notice that it is sitting a little bit proud. I don't know if you can see that from here. You notice it is sitting a little bit proud. So what I'm going to do is, I've only soldered the 1 pin, so I'm going to put my finger on some other pins and then heat this up just so that it'll move and slide in. And then with my fingers, seat it against the board and then let that pin cool. And now that'll hold it in place while we solder the other pins. Now it doesn't matter if the quality of that joint isn't good, because we can come back and fix it later. What matters is that it is mechanically holding that in place. So we can solder the rest of these pins quite easily. And then we'll clean this one up by heating it up, applying a little bit of fresh solder to get it to flow, and voila. So just to demonstrate how much easier it is, if you've got some forceps or hemostats or any other kind of self-holding clamp, just clamp that right on there. Solder 1 pin, and then we'll just solder the other pins. Now it's time for the pin and socket headers, and they need to be perfectly aligned with the other board. You'll see they wiggle around a lot. So rather than soldering them like this, where we have no idea what the alignment's going to be, we're actually going to put the other board into the holder. So we're looking at the back of the board, and I'm putting in the headers. I'm putting the female headers on the front board. Technically, it doesn't matter which way is which. Mate the headers together. So I'm going to 10-pin header into the sockets here. And then you'll see these still wiggle around a little bit. And in order to get them straight, we'll just set one PCB on top of the other, and boom. So what you want is for them to be sitting perfectly flat. It's possible for them to kind of sway either direction, but if you have this board level, then it will sit nice and flat. So now, solder each pin. And then pull these pin headers off of the sockets. And there we go. That is the first board done. And so you may be wondering why we didn't put these in first. And if we had done them first, then we would actually have these pins in the way when we're trying to solder all of this other stuff. So it's good to kind of do them as late as you can. However, on this board, you'll notice that the pins are actually basically in the middle, and we have to solder them from this top side. It is worth soldering them now in order to avoid accidentally melting something that'll show through on the front panel like the display, which we can certainly do by accident if we're not careful. So we're going to start by soldering in the pin headers on the control board. Control side of the board facing out. So those are the two boards held together, and now we can pull. So we want to hold on one board and kind of wiggle this board, and it takes some force, and you want to be careful not to bend the pins as they come out. You should only have to do this once more, but there you go. So that is the first part on the control board soldered, and it is just the pin headers on the back, and they should be perfectly straight up and down. The second time, same as the first, we're going to put some small parts on this board, namely the resistors, and then the order of operations is going to be a little bit different because we've got all of these mechanical components, and I think we've got one diode to do, so we might as well do that right now. This is the BAT85, and that goes down here in the corner. Once again, this is a glass diode. This one has very thin leads, and it has a stripe that matches the stripe on the silk screen. So the easiest thing to do probably are the 100 ohm resistors. We got a bunch of them up in a row right up here. And then we've got 4 more over here for multiplexing the LEDs. With these pin headers installed, it's a little bit more difficult to get access to some of the components, and that's why we didn't install that first on the other board. But here it actually makes things a lot easier because soldering them from the other side, once you've got all the components installed, it's quite difficult. It's probably going to mess with the color temperature a bit, so this footage is going to look really weird. But if you can see it, that's what's important. 3 of these 680 ohm resistors. These go up here for the display. And once again, a lot of these values are fairly approximate, but these 3 are pretty important. If you make them smaller, that is, you make them less resistance, so 500 ohms, then the display will be brighter, but it will draw more current and produce more noise on the power supply. And finally, we've got a smattering of 1K resistors, and they're down over here by the bottom of the board. If you have a very sharp eye, you have probably noticed that I forgot a resistor over here. So this 100 ohm resistor actually goes right there. So now I'm going to throw on the ceramic capacitors. There's 3 chips. Each of them has a 0.1 microfarad or 100 nanofarad cap and a 100 picofarad cap. Now we're going to put on some transistors. In the bill of materials, I specified 5 of these little 2N3906 transistors. We actually only need 3. The bank made an error in your favor. Collect $200, pass go. Not to worry, you just have 2 extra transistors. And then these 2N3904 is the match transistor. One is NPN, one is PNP. And this goes down here by these 3 resistors. What I'm going to do next are the ICs, because they are the next tallest parts. And then the other 2 ICs are shift registers, and this is important to note. The orientation on this chip does not match the others. The notch should still match the notch on the cutout, but it is opposite from how this chip is oriented. One of these big chips is a very flat process. It seldom works very well. On this side here, this chip is oriented this way with the notch on this side, this chip with a notch on this side. So, next I believe we are actually going to stuff this panel full of switches. And these are all 6mm Tact switches. They are through-hole components, and you can see the leads are quite thin and they flex quite a bit under stress. So it's important to be kind of careful when we're putting them in. You should have 1 extra of these, so if you break one, it's not the end of the world. But generally speaking, we want to be quite careful. And it shouldn't take all that much force. If you find yourself having to put a lot of force on it, you probably haven't seated one of the legs correctly. And if you push harder, it's going to bend or break. And with these, it is very important that we get them to sit flush against the PCB. The leads should hold themselves naturally in that flush position. But if we get them kind of skewed off to the side or sitting high, then it's going to be very hard to get the button caps to sit through the front panel correctly. And it may be hard to get the front panel on. So be careful and get all these flush and have the front panel on as possible. So here's an example of one which isn't ready to go in. And as you can probably tell, or you may not be able to, one of the legs is slightly canted out. This one is just a little bit wider, and that can happen during transit. So I'm just going to do this by hand. You might use pliers for it and just bend it a little bit closer to the body of the chip. Still taking a little bit of force. But I can see all the leads are through, and that looks fine to me. And of course, not to forget, there's also one for the glide switch. Alright, now we really want to be sure that all of these are in very flush. So I'm going to take a ruler and set it along the top here, and just make sure that it touches all of them, and that there's no big gaps underneath any of the switches. You can do the same thing from this orientation and just kind of double check that we can't see any of them sticking out proud. So, I think those are in all flat. Let's solder them. We got, how many of this is 70 solder joints to do in one go? Let's see how fast we can do it. And time. I believe that is all. But yeah, I think that took me about 5 minutes if I had to guess. Fortunately, we don't have to clip the leads. So that is all we have to do on the switches. We are now going to do the big front panel components. And this can be a little bit tricky. It requires taking the panel on and off a couple of times. But what we're going to do is start by taking this board out of the holder, because we're going to be soldering this on the other side. And if we're holding it by this, the panel will just drop off the front. All of the potentiometers are the same. They are 100K linear pots. These are the TT brand ones, B100K. And you might have alpha ones or some other brand. That's fine. And, you know, a little bit like the switches, once again, these might get shifted during transit. And so you might have to squeeze these two parts together to get them to fit nicely. So I like to just take the pliers, apply a little bit of pressure, and like so. So once again, these should sit really flat, and you kind of want to double check that they're all straight and parallel. And then we are going through the encoder, which is almost exactly the same story, except these are a lot more rigid because they don't extend quite as far. So I usually have to bend those in just a little bit. And there we go. So that is the front panel potentiometers and encoder in. And we want to seat that on there and make sure that they are soldered in straight. Now, obviously, the panel kind of sits a little bit cattywampus because we don't have the jacks in. So I do like to do the jacks at the same time. What they've got is 3 lugs, which are just regular solder pins, and this one is kind of flexible. So what I like to do is bend this out a little bit and have it offer some spring tension while we mount this in the slot. So you kind of squeeze the outermost lug and then let it go, and it should kind of keep itself in there. Now these, you can see, are sitting flat against the PCB. What's more important actually is that they sit flat against the front panel. That when you pull on the jack, you want to be pulling the body of the jack against the front panel and have that provide the resistance on the cable, because the cable, you know, takes some force to remove. If you have a small gap between the jack and the PCB, that is okay. There can sometimes be about a 0.5 millimeter gap. You want there to be more resistance against the jack, the body of the jack and the front panel, and not on the solder joints themselves. And again, we're going to mount the front panel in the jaws of the holder and not the PCB itself. All right, now we're going to do something which is a little bit tricky, and that is these light-emitting diodes. And these have to be mounted at the correct height. If they're sitting flush on the PCB, they are not going to poke through the front panel. So we've got quite a few of them here. 2 of them are larger, so those are these 5mm, and the others are 3mm. So these 16 that are next to the buttons will use the 3mm, and the one down here by the glide and the gate lead will use the larger ones. Now these are polarized, you have to get them in the right way. The way that we do this is to know that the short leg goes in the square hole. Short and square, or long and round if you like. And again, the 2 big ones go in these, so I would go ahead and do those first so that you don't get them mixed up. The rest of these, of course, follow the same rule. They all have the same orientation, short and square. And what I would like to do is just have you kind of come up with a mnemonic, like you're always going to do this with the right hands, and the long leg will be down, and then that'll go in first. So when you pick it up, just inspect it, make sure the long leg is down. Because there's a lot of these, it's easy to accidentally do one in the wrong orientation. You just want to have something that's easy to do, easy to see. Long leg down, short leg square. What we need to do is use the front panel. And the other thing I would suggest doing right now, actually, is to put the standoff in place over here, because that'll get this at the right height. So if we look in the hardware envelope, there's a whole bunch of stuff. What we need is one of these standoffs and a couple of these screws. We fit a screw in from the back here and then thread the standoff on. So now when we sit this on top, it's all parallel. It's held kind of at 4 corners at the right height, but we need to flip it over and have it be held in the PCB holder. So in order to get this so that the LEDs poke through but don't stick way out, which is fine, if you like that appearance you can certainly do that. What I like to do is just put a little bit of tape over the front panel so that the LEDs sit almost exactly flush with it. So just a big strip right here. And right here. And then a little piece right here. And again, these LEDs are not held on very well. They could fall out. So we are going to very carefully grab both boards, flip this assembly over, and then put the panel in the PCB holder. And then what we're going to do is just grab each of these and then wiggle them around until they find their place in the front panel. You'll find that once they sit down, they don't really move around. And the tape prevents them from poking a long way through. So now that we've got this upside down, we are going to double check that all of these are oriented the same way. So in this particular orientation where the big header is near me and the small header is farther away, we want the long legs on the left and the short legs on the right. That looks good to me. Look on the front, make sure that the tape is holding fast, and then we are ready to solder. Alright, well, we can't do anything about this header being where it is, but we certainly can do something about these leads. So I'm going to go ahead and clip all of these, and then we'll finish the rest. Alright, so now we should have the board with the LEDs all at the right height. So in general, the tape strategy works well. But if you like them to sit a little bit higher, another thing you can do is before you solder, take the panel off and then put a couple of the hex nuts on the jacks and potentiometers, and then seat the panel down again. And that will have the panel sit a little bit further away from the board, and so when you poke them through to the tape, they will sit a little bit further through. A couple more components. We've got these electrolytic caps, we've got these big buttons, and the display. So let's do the capacitors. And all three of these are the same. So we're just going to make sure we use the stripe on the stripe side and set that down. Now this is a little bit tight spacing. What I recommend doing is folding the legs over and then putting a little bit of an S-bend in them. Once again, we use the side with the stripe towards the side with the white line. Bend that you want is a little bit more like that. It's a bit more pronounced. And then you can kind of push down. One thing you want to be careful of is that it is possible to short the legs of this to the wipers of the potentiometer. You don't want that. So this is a little bit tricky. That's why we're saving it for the end when we actually know where these components land. If we do this, with the potentiometers not installed, then we sort of run the risk of accidentally making it more difficult for ourselves. And then the last one is pretty easy. We just have to get it to lay flat. And so we can do that by kind of just putting a 90-degree bend in it as best we can and having it lay flat. And I believe we're good. So now we can get these buttons on properly. These do have a direction. The flat side on this is going towards the bottom of the PCB, and you can see there's a flat on the silk screen as well. And if this is wrong, then the button essentially will be constantly held down because the adjacent pins are shorted. So you really do not want to have that go the wrong direction. And these are a little bit tricky to get situated. So you can see how much play there is between the default position of the button and where we'd like it to be. So what I tend to like to do is to tin one of the pads just while it's sitting there, and then reach around on the other side and push the button up while we're heating this pad up. And then just very carefully with the fingertip make sure it's balanced straight up and down and not rocked off to one side. And then when it's in properly, you should be able to click the button and have it travel normally without hitting the sides of the PCB. And then you can solder the rest of the pins. Solder one. Push this in. And then let that cool. Make sure it's nice and flat. Make sure it pushes, and solder the other pins. Now, last but definitely not least, we've got our big 7-segment display. So you've got the decimal points down here. These need to go at the bottom towards the center of the module. The way I like to do it is to get it as flush with the front panel as possible. So you can see by default there's a little bit of a gap between it unless we push this up. So I just like to have it, again, grab the front panel and then let it rest against it. And it will kind of do that if you don't have it in the right angle. So you want to just kind of be careful and double check once you've got it kind of resting there. And do the pins. There's not much pin sticking through here, so we don't need a ton of solder, but we do want to get it to flow all the way through. And there we go. We are pretty much done soldering. That is all the parts on the Super 16. So now I would recommend that we just do a couple electrical tests to kind of make sure that we're not doing anything crazy. It's really important to do an electrical check. So I'm going to have my multimeter in continuity mode. And I'm just going to check that there aren't short circuits on the power line. So I'm going to do that by touching one to the outer pins, touching one to the middle pins. Good sign. And then we'll try the other outer pin, and then the outer pins, and then double check that the continuity mode is working. So we don't have any short circuits on the power line on this board. Gently mate them together and do the same test. Doesn't matter which polarity we use, but we can switch them both if we like. There we go, we're looking good. Before we go plug this in, we need to do the most important part of any electronics project, and that is visual inspection. So I would say almost, 90% or more of problems during assembly can be found with a quick visual inspection. So around for, in particular, we're looking for solder joints that look dodgy. Anything where we're missing, we forgot to solder, or where we have too much solder and it's bridging. A good thing to have during this phase is a marker, particularly an erasable marker, so that you can just make some marks so that once you find a problem that you want to fix, you remember to fix it. Grab some flux. So there's board 1. Now we'll do the same thing for board 2. Alright, that's looking a lot better. Now let's get these boards a little bit cleaned up. Main tools over this are going to be toothbrush. An old toothbrush is great. Some isopropyl alcohol, rubbing alcohol, and that's pretty much it. I like to pour some in a tray, and then we can dip the toothbrush in it and kind of rinse it, and then we just kind of scrub in one direction to try and get the flux residue off. We don't really want to scrub in circles because then we're just smearing it around. What we want to do is get it to kind of land down here on the paper towel, and every once in a while freshen up the alcohol and clean the toothbrush a little bit. And then as much as we can, we want to get the flux residue that's dissolved in that alcohol off the board, so rather than letting it dry, we're going to blot it if we can. Boards are ready to be assembled and tested, although what we want to do is give these boards a good, 15-20 minutes to dry off completely. In the meantime, what we can do is put on our spacers, one more of these standoffs, and this goes through right here. We've got, and we can just thread on the standoff like so. You can now see that standoff is sticking through, and we can thread this screw into the other side. Good. The other thing we can do is put some hot glue on these capacitors. And on this big capacitor, I'll just put some between the inductors, or the PCB there, on the big cap. It's been a few minutes, should be dry. And here I've got a immutable instruments module tester. Very nice because it's got its own power supply, and you can test various features on it. Right now, we're just going to use it to power the module. So this is the standard Diorac 5-pin connector. And this is the indication for polarity. So the red stripe, which is minus 12 volts, goes on this side. On the whole, it's good to be observant about connecting it the right way. And because this IC wasn't programmed, nothing is happening on the display. But I can touch the regulator and it doesn't feel like it's overheating, which is a good sign. Now I'm going to take my ICSP programmer, plug that in over here, upload the code using the programmer. We can change the values over here, though it looks like the encoder is not being read properly. So that is something we can change. And really what we want to do when we first start it up is just double check that all of the hardware is working. So we know that we've gotten a problem with the encoder. These should, there's this LED down here in the corner that should flash on when you push these buttons. Then we should be able to toggle on and off all of the steps. Alright. We should be able to hit shift and see this button light up. Should be able to play, see the sequence start. Should be able to hit load and be able to go to patch mode. Again, the encoder doesn't work. Save and go to patch mode, shift and back out. So that's looking pretty good to me. Let's see if we can figure out what is wrong with this encoder. So I came back and reflashed it, and it looks like it is working now. So I don't think there was anything actually mechanically wrong. It's future me with the answer to why the encoder wasn't working. It's actually really simple. You see this screw here? This goes through to the standoff on this side, and as you can probably see, standoff is shorting the last pin on the microcontroller to ground. That's because this is the wrong standoff. I just grabbed one out of the bin instead of using the ones that were from the BOM. So if we just swap this out with the right screw, no more short circuit, and the encoder works just fine. But at any rate, we can get the faceplate on now, which is very exciting because we get to put all the button caps on and the hardware and the knobs. So we're going to need our hardware and our button caps. If you haven't done it yet, now is a good time to put in the screw for the standoff. In the bill of materials, these were nylon screws. And they may or may not work, M3 nylon screws. I've never seen them before. I'm just going to throw a couple of these metal screws in the package with all of the kits so that you have them if you don't like the nylon ones. Anyway, what we do now is we fit the front panel on the controls, and then we install the black screw if we've got the black panel, or the fourth silver screw. And then we install 4 washers and 4 nuts. And so these, for the potentiometers, take a 10mm socket. You can just kind of hand tighten that. And these take an 8mm socket. And I'm going to be very honest, these are kind of difficult to get threaded on. I always spend a bunch of time fiddling around with it. Now we're going to put the button caps on. We've got a whole bunch of these, and they're quite easy to lose, so do be careful. Now the thing about this is there are 4 large ones. So the 4 larger ones go up here. And you may be wondering why we waited until the very end to do this. It's because they're much easier to get on when you've got the panel kind of helping you. So the thing to note about this is that they kind of have a square cutout in the bottom, and they go onto a square plunger. So there are 4 ways that they will go on, but you kind of need to, if it doesn't first sit, then twist the button a little bit. And then you kind of just want to push it until it snaps on. And it'll be much easier to do. And again, it does take some force, but if you find it takes a lot of force, try twisting the button a little bit. Yeah, I think I actually am going to take this panel off. Life is struggle, isn't it not? Alright, you can see this one's all cattywampus. Just go very carefully, try and get that nice and aligned. You can see it sort of wants to slide off to one side, and that'll happen sometimes. So, kind of get it braced under the thumb. There we go. Now it's popped on and it's clicking. And that's what we want. Usually that's easier to do with the front panel on, but you know, if it doesn't want to go, it doesn't want to go. So don't fight it, and you can see They fit through nicely once they're on. The other ones, I promise, are very easy to get on with the front panel on. These switches, the little ones, they have a square and slot, and there's really only a couple ways they can go on. And you see here that there is sort of one click that they go on, and then if you push harder, there's another. So a little bit more force, and they go down almost flush with the panel. And last but not least, the glide button, which is the same as the others. And there we go. Put the screw back in. There it is. Finally, we get to do the most joyful part of all and put the knobs on. 4 of these with the pointer and 1 of them without. The one without is for the encoder. You can see there's a flat on one side, and it mates with the flat on the encoder knob. So you just go until they both twist together and then push. And you want to grab it with your thumb and then right behind the encoder so that you can kind of reef on it. And there you go. And you don't want it to touch the panel because then it'll provide friction. So the knobs on the potentiometers are much the same. Find it where it seats and then just push it on. And that is the Super 16, all put together. Alright, so without further ado, let's plug this into the synth and test it out. So I've got these guys wired up to my modular synth over yonder. Let's plug them into the gate and the pitch outputs and program a quick sequence, see what happens. Let's try out the other CV. So that is a pretty comprehensive feature test. We know that we've got the display, we've got the encoders, we've got the knobs, we've got the memory, all the buttons, everything seems to be working. All that remains to do is calibrate the output. I'll show you how to do that in another video. This one has gone on long enough. Thank you very much for watching. I hope that clarifies any questions you might have about how to build the Super 16. And please let me know down below if there's anything that you're still unclear about or that you're struggling with. I would be more than happy to help you. I'm also going to go ahead and start writing up the full build guide. That'll be in PDF format. It'll be online. So I will link to that down below when it's finished. But right now, I got to get to uploading this video because there's a lot of footage to edit, and it's going to take me a little while to get through it. So thanks for checking it out. Thanks for tuning in. I'll see you next time.